Today we are going to talk about a new Intel technology called direct line interface and why it can be interested for development, for researcher, and how to use in a practice. Our research team, Maxim, Goryachy, it me. I'm a security researcher and hardware engineer, finding bugs and vulnerability in modern embedded system.
I am a Ermolov. I am system programmer. I'm writing, debugging, reverse engineering various system low-level software and firmware.
And Dmitry Sklarov, it's well-known reverse engineer who did research electronic books and authentication of digital photos and smartphone forensics. Here you can see our contacts on the slide, and you can feel free to communicate with us for any question you're interested about our research. And on this slide you can see our previous related talks. It's tapping into the core from CCC and Intel MEA the way of the static analysis from Troopers. And today we will discuss about the power of Intel hardware development debugging capabilities, and each capabilities existing for a long time, but those were unavailable for public. We will reveal all technology stack designed by Intel for hardware debugging and validation, and show how this technology is related with IEEE standards, more known as JTAG, an industry standard for hardware debugging and validation. Mark, please.
First of all, why is this always worthy of our attention, and why we speak about now? We think all you know that a software debugging as well as dynamic analysis is vital for any software developer or security researcher. This is where a special type of program called debugger comes into the play. But it is not a secret that any software debugger is limited by the fact it is a program itself, and it is executed on the same environment as debugged program. Also, it must have a same or higher privileges level. For example, you can debug OS kernel by user mode debugger. You can't also debug Wi-Fi firmware by OS level debugger, and so on. So it is also must be clear that any software debugger influences debugger. So it works not exactly as it would work without attached debugger. So we ask, is there some debugger that can debug all types of software? That is, debugger having highest privileges. Is there any able to debug hypervisors or VMX root operations? Is there any able to debug system management mode or new software guard extensions from Intel? Also, is it possible to debug Wi-Fi firmware? The answer, it is possible. It is a hardware debugger. Someone calls it JTAG debugger. Intel calls it DFX abstraction layer, or DAL. Unfortunately, until recently, an x86 hardware debugging was unavailable for ordinary security researchers and experts because of its cost and because non-disclosure agreements the well-known x86 provider required. But now we are here to make you happy and to announce that now an x86 hardware debugging is available for everyone, and cost of it now is almost nothing. Please meet Intel Direct Connect interface. Intel direct, in brief, now Intel introduced new technology called direct connect interface. So you can debug new system using ordinary USB 3 debug cable through any external USB 3 port. DCI is transferred to real hardware debugging, not to some software agent, by for real JTAG. Also, there is special device called SVT-CCA, Intel Blue Box. It can be purchased from official site, but unfortunately we're signing NDA. But there is only one thing that this device can do, but USB 3 debug cable cannot. It is debugging of powered off or sleeping systems. That is a very special case. A software to perform such debugging is available without signing any NDA. Here at the top we have placed image showing connections of DCI from Intel documentation. At the bottom we feature a stack of entities used in x86 hardware debugging. Further, we will consider the entities in details and start from DFX. DFX is a collective term for next two abbreviations, DFT and DFD. DFT stands for Designed for Testing, and DFD stands for Designed for Debugging. DFT is a set of mechanisms used for manufacturing defects finding. For example, for electrical verification of signal lines or pin contacts. Standard DFT is generally based on ordinary boundary scan JTAG commands, but Intel considerably extends its DFT in its branded Silicon View technology. The FD is joins all internal chip-level logic to organize hardware-level debugging of code sequences executed by chips. The FX is connected to external world by special thing called embedded DFX interface, or DFI. This bridge connects the FX with industry external standards like USB. Also, there is special device in PCH or Intel Platform Controller Hub, Southern Bridge, that its function is to control access to the FX. It's called the FX aggregator. We have placed an image showing its internal registers on the bottom of the slide.
And in addition, I want to say that its technology, the FX, it's private Intel technology, which can you help to debug all device on the chip. For example, Intel Management Engine, for example, Intel ACH Core, for example, ECC device which controlled clock on in all system. And in patient we found the describe of this technology, how you can see Intel property, intelligent property. It means some device core connect with with sharing JTAG devices, and you can get this device from industrial interfaces, for example USB, or in patient, for example Ethernet.
Next, let's talk about software part of the technology stack. It is presented by the FX abstraction layer, or DAL. This last library exposes all the power of the FX to software model. As we found, DAL has large history. It supports various platforms and CPU architectures, and designed to work with different debug ports and hardware probes. For example, we have seen it is working with old ITP XDP debug port, also with some PCIe XDP device, and obviously DCI USB. We convinced that DAL is a core of old instruments those Intel uses for its testing and debugging of its hardware and firmware components. So it is provided by applications that base it on it. For example, you can download it as part of Intel Systems Studio from trial version of the Studio from official Intel website.
Of course, without any NDA signed, and it's free in public. You can download this trial version on the 1 month, and you can use it in your work.
It is by default installed in root drive into DAL folder, and you can use from this folder. DAL is almost written in C# and has strong structural arrangement. The main job of DAL is to construct binary packages according to some proprietary protocol, those sent to hardware probes connected to platforms debug port. DAL has Python command line utility called DAL CLI. It has some subset of classes wrapping DAL functionality. You can do more with Python CLI. Also, DAL has GUI configuration tool to set up target platform. DAL has hierarchical architecture that is based on node notion. There are two types of nodes: physical nodes and logical nodes. Physical nodes hierarchy represents tree of physical devices originating from hardware probe. It includes tap ports, E2C buses, and OBS pins. So there's all that standard old ITP XDP port includes.
Logical nodes represent certain functionality that can be used for perform debugging stuff. Unfortunately, in public version of System Studio, you cannot debugging, for example, GT cores and uncores, CPU uncores, because on this device, I don't have a special configuration file for public System Studio.
To show power of DAL, we are listing here what can be done using its facilities. The most useful tasks are debugging of VMX root operations or hypervisors, and to debug software guard extensions or Intel SGX. We have found function to read and write enclave memory we think it is only applicable for debug enclave, not for production. But there is there are also functions to enclave to access enclave control structures. For example, to access enclave page cache map and to access thread control structures and state safe area. Also in DAO there is some functionality that working on only special types of CPU. Call it it is debug versions of CPU. And for example, you can access PCI bus without halting of CPU. Also, you can access machine check exceptions, machine check errors, bugs, and some other functional. Also, using DAL, it is possible to access internal PCH devices. There is a large set of these devices. It is you can access IOSF sideband. If you know that is IOSF, it is architecture of internal architecture of PCH. It is there is some thing called sideband. It is for maintain of internal devices, IOSF sideband, and you can access it with DAL. Also, you can access Trace Hub Intel power management controller.
But in addition, I want to say that Intel said that you can debug SGX only if you have special some private key, and it don't available for
without signing.
Without signing NDA, yeah. And also in patient, we found that as a description of DCI protocol. You can see it's XCI packet packed into a simple USB packet, and also you can see format of packet, and in this packet consist CRC code, special ID, message ID, and sender ID. You can see this value in patient, or for example in Wireshark. And if when in our previous talks at CCQ conference, we did not disclose details of DCI runtime activation because it's vulnerability actually. Now we can do it from Skylake, from PCH for Skylake CPU. There is special hidden devices P2USB. You can unhide this device if you write
special control register.
Yeah, in special control register for unhide this device. And this device has two interfaces for access to inside band, full interface and light interface, called sideband register access. On all systems which we checked, P2USB device Mimeo mapped at physical address AFD and 0000. And how you can activate the device which connected through sideband? You need now a special index. You can see called target port ID. In documents, we found that for DCI, its index equal B8. And you can shift this index on 18 and write 10 in hex in register DCI control register. This it description you can find in documents on mobile PCH platforms. And how you can see on the screenshot, the activate is successful if you have value not equal 0.
The vulnerability was actually in that this register was not locked by UEFI firmware, by Intel reference UEFI firmware. So you can activate it from booted OS or any thing that give access to physical memory.
And sometimes these settings save after reboot. And you can try to activate it capability in once and use it after reboot. And how you can see Intel published security bulletin, and Lenovo published it, and on this slide you can see the list of checked devices which we used in our work. It's Gigabyte, Bricks, and Asus mainboard. But unfortunately, not all platforms have access to CPU JTAG, and we investigate that, and we think that the line between the JTAG line between CPU and PCH has broken, and we try to revoke these lines, and it's work in progress. You can see how I soldered this line, and we have the main task of us on this moment. It try to access to JTAG for Intel Management Engine or ECH, and turn on JTAG for graphical core on internal graphic cards in CPU, and activate hot ham technology. It's special Intel debug technology which can help manufacture tested
perform DFT tasks
yeah.
For production systems.
And small present, when we investigate the internal PCH devices, we found hardware random generation in PCH. How you can see, it have index D2 in hex, and
can be used from P2SB device.
Yeah.
It is a real hardware number generator.
This hardware generator used using in management engine. And thank you very much for your attention. Please question.
Thanks for the talk. Anybody got questions? Nobody? Also not after a second thought. Okay, then I would like to thank you for your talk.
Thank you very much.
Thank you.